Now in this lecture we'll find out the radius of a circle. In the drawing we have the right triangle, triangle ABC. Angle ABC equals to 90 degrees in its size. And inside this right triangle ABC we have this circle. In addition, we know that this is line segment AS that is equals to 1 unit in its length. This is line segment ST that is equals to 3 units. And this is line segment TC that is equals to 2 times square root of 3 units in its length. Repeat again that our mission is to find out the radius of this circle. So first of all, we define the center of this circle, this point as O. And we define the radius of this circle as x. In the next step, we join points O and Q together by a straight line. So what is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of the circle, and ends at point Q, that is the point on the circle itself. So this is exactly the definition of a radius. Therefore OQ is the radius of this circle. This is equals to x according to our definition. You can actually implement here rule 1. I'll repeat quickly on rule 1. According to rule 1, the tangent to the circle is perpendicular to the radius drawn to its point of tendency. So in the drawing we have a circle, and we have, this is tangent AB, that is tangent to this circle at point M. Point M is the point of tendency of tangent AB with this circle. And we have the radius OM that is equals to R. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals 90 degrees and this angle also equals to 90 degrees according to this rule 1. So we can actually implement rule 1 in our drawing. In our drawing, we have the radius OQ that is drawn to point Q, that is the point of tendency of tangent BC with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees. This angle also equals to 90 degrees according to rule 1. Likewise, we join points O and P together by a straight line. OP, line segment OP is the radius of this circle that is equal to x. And we have here the radius OP that is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If tangent AB is perpendicular to PO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. So inside this quadrilateral QBPO, we have 1, 2, 3 right angles. The sum of 3 right angles is equals to 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total the sum of those four angles, it must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here, the missing fourth angle here must be equal to 90 degrees in its size. In order to complete the sum of the angles inside this quadrilateral POBQ to 360 degrees, the missing angle here must be equal to 90 degrees in its size. So inside quadrilateral POBQ we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a left angle, not a square. So we eliminate for this quadrilateral POBQ is a left angle. And we also note that the opposite sides of a left angle are equal to each other. So a left angle POQB, side PO must be equal to the opposite side BQ. But PO equals to x, therefore BQ must be also equal to x because they are equal to each other. Likewise, according to the same rule, in the same triangle, in the same rectangle POQB, side OQ must be equal to the opposite side PB. But OQ equals to x, therefore PB must be also equal to x because they are equal to each other. Okay. So actually found out that quadrilateral POBQ is not a rectangle but a square. In the next step, we'll define the length of this line segment AP as A. And we define the length of this line segment QC as B. In the next step, we'll implement Rule 10 in our drawing. I'll repeat quickly on Rule 10. According to Rule 10 is true in any circle. So in any circle, if we have, this is common external point P, and from the common external point P, we draw tangent PT, that is tangent to this circle at point T, and we have also chord BA, or the extended chord BA, touches the external point P. So in this drawing, the following equation will be true. That PT square will be equal to PA times PB. Again, PT square will be equal to PA times PB. Okay. You can actually implement Rule 10 in our drawing. Why? Because in our drawing, we have the common external point A. From the common external point A, we have tangent AP that is tangent to this circle here at point P. And we have also chord TS, or the extended chord TS, touches the external point, the common external point A. So all the requirements of Rule 10 are met, or all the requirements are satisfied, and therefore you can implement here Rule 10. So according to Rule 10, the following equation will be true, that PA square or AP square must be equal to AS times AT. Repeat again. According to Rule 10, if you focus on the common external point A, the following equation will be true, that AP square equals to AS times AT. So this equation is the implementation of Rule 10 in our drawing. So AP square, so what is AP? AP is A, therefore AP square is A square. And it must be equal to AT AS is 1, according to what is given as the equation, times 80. From the drawing it is very easy to see that 80 in total equals to 1 plus 3. So the proposal actually found out that according to rule 10, a square equals to 1 times 1 plus 3, or a square equals to 1 times 1 plus 3 is 4, so 1 times 4, that is 4. A square equals to 4. Here we take a look out of this equation, and finally we get that a equals to the square root of 4, that is 2. So actually I found out that a equals to 2, so I write it down here. A equals to 2. In the next step, we'll implement rule 10 and the common external point C. So from the common external point C, we have tangent CQ, that is tangent to this circle here at point Q, and we also have chord ST, or the extended chord ST, touches the common external point C. So all the requirements of rule 10 are met, and therefore we can implement in rule 10. According to rule 10, the following equation will be true. That CQ squared equals to CT times CS. Repeat again. According to rule 10, CQ squared equals to CT times CS. CQ equals to B according to our definition, therefore CQ squared equals to B squared, and it is equals to CT equals to 2 times square root of 3 times CS. From the drawing it is very easy to see that CS in total, or SC in total, equals to 3 plus 2 times square root of 3. So in conclusion, I actually found out that B squared equals to 2 times square root of 3 times 3 plus 2 times square root of 3. Here we will open the brackets on this side of the equation, and we get that B squared equals to 2 times 3 times square root of 3 plus 2 times square root of 3 times 2 times square root of 3 is 12, because 2 times 2 is 4, and square root of 3 times square root of 3 is 3, and 4 times 3 is 12. Here we substitute 12 by 9 plus 3, and we get that B squared equals to 12, that is 9 plus 3, plus 2 times 3 times square root of 3. This expression is very similar to the algebraic identity that A squared, it says that A squared plus B squared plus 2 times A times B equals to A plus B squared. If we just substitute A in this expression by 3 and we substitute b by square root of 3, we naturally get that a squared plus b squared plus 2 times ab equals to exactly to 9 plus 3 plus 2 times 3 times root of 3. Why? Because if a equals to 3, then a squared is 3 squared, that is 9, plus b squared. B equals to square root of 3, therefore b squared equals to the square root of 3 squared, that is 3, so we have here 9 plus 3, plus 2 times a, that is 3, times b, that is equal to 3. So we found out that a squared plus b squared plus 2 times ab equals to exactly 9 plus 3 plus 2 times 3 times root of 3, if we just substitute a by 3 and b by square root of 3. And therefore, those two sides are equal to each other. So, a squared plus b squared plus 2 times ab equals to a plus b squared. That is to say, it is equals to a, that is 3, plus b, that is square root of 3 squared. Or in other words, according to this algebraic identity, 9 plus 3 plus 2 times 3 times root of 3 must be equal to 3 plus square root of 3 squared. And therefore, b squared equals to this expression, but those two expressions are equal to each other, therefore this expression must be also equal to b squared. In conclusion, we found out that b squared equals to 3 plus square root of 3 squared. So here we take a root out of this equation and we get that b equals to 3 plus square root of 3. Square root of 3 equals to 1.732, therefore 3 plus square root of 3 will be equal to 4.732. In conclusion, we shall find out that b equals to 4.732. So I write it down in the original drawing. We actually found out that this line segment QC equals to b and b equals to 4.732. And we have already found out actually that a equals to 2. In the next step, we'll implement the Pythagoras theorem on this right big triangle ABC. Here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right angle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right big triangle ABC is AC, therefore the square of the hypotenuse is AC squared, and AC squared must be equal to AB squared plus BC squared. Repeating again, according to the Pythagoras theorem, in the right big triangle ABC, AC squared equals to AB squared plus BC squared. So AC squared, what is the length of AC? The length of the hypotenuse AC, from the drawing it is very easy to see that AC equals in total to 1 plus 3, that is 4, plus 2 times square root of 3. So in total AC equals to 4 plus 2 times square root of 3. Therefore AC squared will be equal to 4 plus 2 times square root of 3 square, and it is equals to AB square. AB equals to x plus 2. So the numerator is very easy to see that AB equals to x plus 2. Therefore, AB square equals to x plus 2 square. Plus BC square. From the drawing, it is very easy to see that BC equals to x plus 4.732. Therefore, BC square will be equal to x plus 4.732 square. In conclusion, I have found out that 4 plus 2 times square root of 3 square equals to x plus 2 square plus x plus 4.732 square. So what is the value of 4 plus 2 times square root of 3 square? Actually, 4 plus 2 times square root of 3 square is equals to 55.7128, and it is equals to x plus 2 square. X plus 2 square equals to x square plus 2 square, that is 4, plus 2 times x times 2, that is 4x. And we also plus x plus 4.732 square. It actually equals to x square plus 4.732 square. That is actually equals to 22.3918 plus 2 times x times 4.732. That is actually equals to 9.464 x. Again, 2 times x times 4.732. In total, this equals to 9.464 x. So in conclusion, I should have found out that 55.7128 is equals to, here we have, the other side of this equation, we have x squared plus x squared is 2x squared. And we have also here 4 plus 22.3918 is equals to 26.3918. And we have also here 4x plus 9.464x equals to 13.464x. In conclusion, I shall find out that 55.7128 equals to 2x squared plus 26.3918 plus 13.4164x. Here we subtract 55.7128 from this equation. And we will get that in this side of the equation we left with nothing, that is to say 0. In the other side of the equation we have here 2x squared, and we have here 26.3918 minus 55.7128. It is equals to minus 29.321, and we have here also we have to add plus 13.464x. So here we divide this equation by 2, and we get that 2x squared over 2 is x squared, and we have minus 29.321 over 2 is minus 14.66, and we have here also 13.464x over 2 is equals to 7.232x. In conclusion, we actually found out that x squared plus 3.232x minus 14.66 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus 7.232x minus 14.66 equals to 0, the coefficient a equals to 1, the coefficient b equals to 7.232, and finally the coefficient c equals to minus 14.66. So we put the data for our specific quadratic equation inside the general formula for x in order to find out the value of x in our specific quadratic equation. Repeat again. We just put this data for our specific quadratic equation, x squared plus 7.232x minus 14.66 equals to 0. We put this data of A, B, and C inside this general formula for x in order to find out the value or the values of x in our specific quadratic equation. I will remind you that x in our equation is the radius of this circle. That is actually the radius that we are looking for. So we'll do it now and we'll get that x equals to minus b equals to 7.323, b equals to 7.232, and therefore minus b equals to minus 0.7232 plus minus square root of b square. B is 7.232, therefore b square is equals to 52.3018 minus 4 times A is 1, so minus 4 times 1 is minus 4 times C, that is minus 14.66, so minus 4 times minus 14.66 is equals to 58, so it is plus 58.64 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So in conclusion, we actually found out that x equals to minus 7.232 plus minus, inside the root we have 52.3018 plus 58.64. That is actually equals to 210.9418 divided by 2. So x equals to minus 7.232 plus minus, and the square root of 110.9418 is equals to 10.53 divided by 2. So here we have two solutions that are possible for x. One of the solution is negative because we have minus 7.232 minus 10.35, that is definitely a negative number, and because of the fact that if x is the radius of this circle, the radius is the length, and the length must be a positive number, therefore we will cancel the negative solution and we left only with the positive solution that is possible for x. The positive solution for x is that x equals to minus 7.232 plus 10.53 over 2. So it is equals to 10.53 minus 7.232 equals to 3.3 divided by 2. So x equals to 1.732 units in its length. So the radius of the circle equals to 1.732 units. Again, the radius of this circle x equals to 1.732 units. So in the next step, I'll summarize the lecture. In this lecture, we found out the radius of this circle. In the drawing, we have a right triangle ABC. Inside this right triangle ABC, this is again ABC is equal to 90 degrees inside, and inside this right triangle ABC we have this circle, and our mission is to find out the radius of this circle. In addition, we know that this is line segment AC that is equal to 1 unit in itself, this is line segment ST that is equal to 3 units, and line segment TC, this is line segment TC that is equal to 2 times square root of 3 units in itself. Again, our mission is to find out the radius of this circle. Okay, so first of all, we define the center of this circle, this point as O. We define the radius of this circle as X. And then we join points O and Q together by a straight line. What is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of the circle, and ends at point Q, that is the point of the circle itself. Therefore, OQ is the radius of the circle that is equal to X according to our definition. We have here the radius of OQ that is drawn to point Q, that is the point of tendency of the BC with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and P together by straight line. OP is the radius of the circle that is equal to X according to our definition. Again, the radius OP is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. So inside quadrilateral POQB we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this missing fourth angle must be equal to 90 degrees in its size. So inside this quadrilateral POBQ we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to this quadrilateral POBQ as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle POQB, side PO must be equal to the opposite side BQ. But PO equals to X, therefore BQ must be also equal to X. Likewise, according to the same rule, in the same rectangle POBQ, side OQ must be equal to side PB. But OQ equals to X, therefore PB must be also equal to X. So actually we found out that quadrilateral POQB is not a rectangle but a square. In the next step, we define this line segment APSA and we define this line segment QC as B. And then we implemented here rule 10. Repeat quickly on rule 10. According to rule 10, that is true in any circle, if we have here, this is common external point P. For the common external point P, we have tangent PT, that's a tangent to the circle point T. And we have also chord BA, the extended chord BA, such as the common external point P. So in this drawing, the following equation will be true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. We can actually implement all 10 in our drawing. One because in our drawing, if you focus on the common external point A, from the common external point A, we have tangent AP, that is tangent to the circle point P, and we have also chord TS, the extended chord TS, such as this common external point A. So all the requirements of rule 10 are satisfied, all the requirements are met, therefore we can implement a rule 10. According to rule 10, AP square equals to AS times AT. Again, AP square equals to AS times AT. Repeat again. According to rule 10, AP square equals to AS times AT. AP is A, therefore AP square is A square, and it is equal to AS. AS is 1 times AT. AT is 1 plus 3. In conclusion, we found out that A square equals to 1 times 1 plus 3. 1 plus 3 is 4, so A square equals to 1 times 4, that is 4, so A square equals to 4. We took out of this equation and finally found out that A equals to the square root of 4, that is 2. Here A equals to 2. Implemented rule 10. And the common standpoint point C. From the common standpoint point C, we have tendency Q, and we have code ST, and the extended code ST touches point C. So all requirements for rule 10 are met, therefore we can implement a rule 10. According to rule 10, CQ square equals to CT times CS. Again, CQ square equals to CT times CS. So repeat again, if we focus on the current standpoint point C, according to rule 10, CQ square equals to CT times CS. CQ equals to B, according to our definition, therefore CQ square equals to B square, and it is equals to CS. CS equals to 2 times square root of 3. Again, CT equals to 2 times square root of 3 times CS. CS equals to 3 plus 2 times square root of 3. So in conclusion, option found out that B square equals to 2 times square root of 3 times 3 plus 2 times square root of 3. Here we open the brackets on this side of the equation and finally found out that B square equals to 2 times 3 times square root of 3, and 2 times square root of 3 times 2 times square root of 3 is 12. In conclusion, we found out that B square equals to 2 times 3 times square root of 3 plus 12. Here we substituted 12 by 9 plus 3, and we found out actually that B square equals to 12, that is 9 plus 3, plus 2 times 3 times square root of 3. So this expression 9 plus 3 plus 2 times 3 times square root of 3 is very similar to the algebraic identity that A square plus B square plus 2 times AB equals to A plus B square. If we just substitute A in this formula, this algebraic identity, if we substitute A by 3 and we substitute B by square root of 3, we will get actually that A square plus B square plus 2 times AB equals to exactly to 9 plus 3 plus 2 times 3 times square root of 3. Why? Because if A equals to 3, then A square equals to 3 squared, that is 9. B equals to the square root of 3, therefore B square equals to square root of 3 squared, that is 3, plus 2 times A is 3 times B, that is square root of 3. We actually found out that if we substitute A by 3 and B by square root of 3, A square plus B square plus 2 times AB equals exactly to 9 plus 3 plus 2 times 3 times square root of 3. But according to this algebraic identity, A square plus B square plus 2 times AB equals to A plus B square. That is to say, this expression also must be equal to A plus B square when A equals to 3 and B equals to the square root of 3. Okay, so we can substitute this expression by A plus B square. A is 3 and B is equal to 3, therefore A plus B square in total will be equal to 3 plus square root of 3 square. And this expression equals to B square, and those two expressions are equal to each other, therefore this expression must be also equal to B square. So in conclusion, we actually found out that B square equals to 3 plus square root of 3 square. Here we took out of this equation, and finally found out that B equals to the square root of 3, to 3 plus square root of 3. Square root of 3 is 1.732, therefore 3 plus square root of 3 equals to 4.732. If we found out that B equals to 4.732. If B equals to 4.732. In the next step, we implemented the Pythagoras theorem on this right triangle, right big triangle, triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of this right triangle ABC is AC, therefore the square of the hypotenuse is AC square, and it must be equal to AB square plus BC square. So in conclusion, I should found out that according to the Pythagoras theorem, in the right big triangle ABC, AC square equals to AB square plus BC square. AC is 4 plus 2 times root of 3, therefore AC square is 4 plus 2 times root of 3 square, and is equals to AB square. AB is x plus 2, therefore AB square is x plus 2 square, plus BC square. BC is x plus 4.732, therefore BC square is x plus 4.732 square. Here 4 plus 2 times root of 3 square equals to 55.7128, and it is equals to x plus 2 square. X plus 2 square equals to x square plus 2 square, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 is equals to x square plus 4.732 square, that is 22.3918, plus 2 times x times 4.732, that is equals to 9.464x. So here we have 55.7182 equals to x square plus 4 plus 4x plus x square plus 22.3918 plus 9.464x. So in this order of the equation we have 55.718, so I copied it here. Here we have x square plus x square is 2x square, and we also have 4 plus 22.4918, that is 20x.4918, and finally we have here 4x plus 9.464x, that is equals to 13.464x. Here we subtracted from this equation for 55.7128. So in that side of the equation we have nothing, 0. In the other side of the equation we have 2x squared and 26.3918 minus 55.7128 equals to minus 29.321. And we have to add to this equation also 13.464x. Here we divided this equation by 2 and finally found out that x squared plus 7.232x equals to 0. And this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c, this general formula are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following general formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. So in our specific quadratic equation, that is to say x squared plus 7.232x minus 14.66 equals to 0, the coefficient a equals to 1, the coefficient b equals to 7.232, and the coefficient c equals to minus 14.66. So we put the data inside the general formula for x, and we actually found out the values or the values of x for our specific quadratic equation. X in our specific quadratic equation is the radius of this circle. Okay, so we put the data for our specific quadratic equation in this general formula in order to find out in our specific quadratic equation. We did it here and we found out actually that x equals to minus b equals to 7.32232, therefore b squared is 7.232 plus minus square root of b squared. B is 7.232, therefore b squared is 7.32 squared, it is 52.3018 minus 4 times a times c. So a is 1, so minus 4 times 1 is minus 4 times c, that is minus 14.66. So minus 4 times 14.66 equals to 58.64 divided by 2a. A is 2, so 2 times a is 1, so 2 times 1 is 2. And actually found out that x equals to minus 7.232 plus minus, and 52.3018 plus 58.64 equals to 110.9418 divided by 2. So x equals to 17.232 plus minus the square root of 110.9418 is 10.53 divided by 2. So x equals to minus 3. So we have here two solutions that are possible for x. The negative solution is incorrect solution because of the fact that x is a radius and the radius is a length and the length must be a positive number. So only we take into account only the positive solution for x, and the positive solution for x is equals to 7.232 plus 10.353, that is 3.46 divided by 2. 3.46 divided by 2 is 1.732. So in conclusion, actually found out that the radius of this circle x equals to 1.732 units. Okay, thank you very much.